NDB Technologies presents the AE-150 Partial Discharge Localization System. In this video, we'll cover basic operation of the hardware and software for successful partial discharge localization in oil-filled power transformers. Here's how it works. The AE-150 main module is magnetically mounted on the power transformer tank. An electric type sensor, in this case our HFCT, is installed around the transformer tank ground cable. The wireless phase synchronization module is connected to a line frequency voltage source that would be nearby. A computer is used to control and retrieve data from the AE-150. In this case, we will use the wireless communication option. Acoustic waves are generated by PD inside the transformer and will be measured by the system's 4 acoustic emission sensors. Electromagnetic PD waves are coupled to the transformer tank and will flow towards ground. These PD signals are measured by the AE-150 through the HFCT type sensor. The measured PD is then correlated to power line frequency through the use of wireless phase synchronization modules. The computer will then retrieve data and generate a detailed report. For the sake of this video, a demo tank will be used. One of the first steps requires to identify an origin point on the tank with X, Y, and Z axis. Refer to the transformer schematics or use a measuring tape to get the tank dimensions and keep the values for later. Apply a thin layer of acoustic couplant on all 4 acoustic sensors. Mount the AE-150 on the tank and press each acoustic sensor to ensure optimal contact. Measure the location of the instrument on the tank from the point of origin and keep the values for later. Turn on the instrument. Connect the HFCT test leads to the AE-150 PD input connector and attach the sensor around the transformer's ground cable. Install the wireless synchronization module in proximity of the instrument. On the computer, click the Mirador-Tx icon to start the software. Click Create New to create a new test session. The file name is defined with the date and hour. Type in the transformer serial number. Enter the previously measured transformer dimensions. A graphic representation is located on the left of your screen. Now it's time to set the communication mode. Click the Communication tab, select Wireless and the appropriate communication port. Click Auto Detect to establish communication between the PC and the AE-150. In the Position tab, type the previously measured AE-150 position on the tank. A graphic representation is then displayed on the left of the screen with the tank dimensions, and in green, you can view the 4 acoustic sensor locations. In the Control tab, click Auto Set to automatically set the gain amplification levels for all sensors. This may take a few seconds. Once completed, you have access to a variety of preset operation sequences. You can begin with PRPD, and in this case, we'll use a high resolution selection. Then click Start. Data will be acquired and transferred to the PC. This step may take a few moments. Once completed, the status bar will display Ready. In the Side tab selection, click Data Analysis, and then select PRPD. Select PRPD acquisition files from the top left list. PRPD graphs are displayed for each channel, acoustics and electric. In this example, partial discharge activity is quite clear. On the PD channel, you can slide the sidebar to visualize the number of occurrences. Use the start and end cursors to select an angular type window trigger. The bottom thresholds should also be set for amplitude type triggering. Once completed, click on Set Trigger Window. Then you can go back to the AE-150 control in the Side tab. As you can see here, the trigger window selection have now followed through for the next measurements. Here we have selected the waveform 1024 PD type measurements. Then click Start. This step may take a few moments. Once completed, return to Data Analysis Side tab and select the Waveform tab. Use the Zoom tool to zoom in the acoustic waveforms. In the Calculator tab, click on Auto TOA tool. This will use an automatic positioning of the cursors. Click on Create Pinpoints and then click Accept. Click on Create Vectors, then click Accept. A graphic representation is located at the bottom. In order to create crossing vectors, the AE-150 instrument should now be installed at a different location. Measure the new location values for the instrument from the origin point. In the AE-150 Position tab, type the new location values. A graphic representation of this new position is presented on the left with the tank dimensions and the 4 acoustic sensor locations. In the Control tab, select Waveform 1024 PD preset and then click Start. This step may take a few moments. Return to Data Analysis Side tab and select the second waveform acquisition from the list. Use the Zoom tool to zoom in the acoustic waveforms. In the Calculator tab, click on Auto TOA. Click on Create Pinpoints and then click Accept. Click on Create Vectors and then click Accept. A graphic representation is located at the bottom. To visualize the end results, click the Localization tab. Select all pinpoints and vectors that you have previously accepted from the list, and then click Keep. The graphical representation of the tank shows crossing vectors and pinpoints that relate to the source location of the partial discharge inside the tank.